All right, so for today, we're looking at subsets. Well, not today. This lesson is based on subsets. The definition states a subset is a set whose members are all contained in another set. So basically, a subset is a part of another set. Before we move on, some additional symbols that we must learn. We're going to add them to the ones that we did previously. We have the empty set, which is denoted by the little, this here, the O with a slash in it. That's the, represents the empty set. And we have the C represents is a subset of, and the C with the slash represents is not a subset of. So for example, we can say if A and B are two sets and A is a subset of B, then we can write A is a subset of B using the symbol, the C, which represents is a subset of. So basically, just a quick recap, we can say, all right, we have the set which has one, all right, let's use a circle. Let's use this as a circle. We have a triangle and we have a square. And let's say this is set A. If we are to have set B would be something like if we have the triangle and the square, we can say that B is a subset of A. B is a subset of A because B comes from A. So looking at this example here, let me just take this off. This example where we have the example explaining subset. We have the set B here, and the set B has 1, 2, 3, 4, 5, and we have set A being 1, 2, and 3. So we can easily say that A, in this case, is a subset of B. Same thing here. Looking at this example here, we can just change this color. At this example, where we have A, B, and C, curly brackets A, B, and C, we will have, looking, if this here, this that's listed here, these are the subsets of A, B, and C, because these can all be found within this set. All right, so something to note that the empty set is always a part or is always a subset of a set. As we move on, you'll see that. Now, to calculate the number of subsets within a set, we can use the formula 2 to the n, where n represents the number of elements within the given set. So if we are to find, let's use this example here, A, B, and C. We have set A, B, and C. We have A, we have B, and we have C. Let's find the subsets of this. So to find a subset, we use 2 to the n power, and we know that n represents the number of elements within the given set. So we will have 2 to the n power. There are 3 elements in this set, A, B, and C. So we have 2 to the 3rd power. And you know that 2 to the 3rd power is actually 2 times itself 3 times. It's not 2 times 3. It's 2 times 2 times 2. We work this out, we have 2 times 2 is going to give us 4, and 4 times 2 is going to give us 8. So in a total, we will have 8 subsets within this set, A, B, and C. And if we are to count here, let me just take off the circle. If we are to count here, count the elements here. We have 1, let's start from the bottom. We have 1, 2, 3, 4, 5, 6, 7, 8. And if you notice that even though that this is a set A, B, and C, that when we look for the subsets, we list the subsets of this set, you find that A, B, and C comes back here again. So A, the set itself, is a subset of the set, along with the empty sets. When you're listing the elements of a set, remember that you must state the set itself, and you have the empty set, which those are always a part of the set. All right, so let me clear here. So remember, when we're looking for the number of subsets, you use the formula 2 to the n power, where n stands for the number of elements in the set, and you just work that out, and you have, that will give you the number of subsets that are going to be in that set in total. Now, if we were to try this, if we are to try this one here, where we have B, but I'm not going to write it. We have B is equal to 1, 2, 3, 4, 5. We will have, all right, let's use 2 to the n power is equal to 2. We have 5 elements, 2 to the 5th power. This is going to equal, this here is going to be equal to 2 times 2. So big 2 times 2, that's times 2 times 2 again. Let's see, that's 1, 2, 3, 4, 5. All right, so 2 2's 4, 4 2's 8, 8 2's 16, and 16 2's is going to give us 32. 32, let's see if I'm correct. 16 times 2, we have 16 times 2, which is going to give us, yes, that's correct, 32. So if we are to look for the number of elements that are going to be in B, 1, 2, 3, 4, and 5, which has 5 elements, the number of subsets in total that will come from this set is going to be 32. Okay, so let me clean this here. And I'm gonna go down. So for example, all right, so that's the part that we did here. The part that we did here, up here, we did that. To calculate the number of subsets in the set A, B, and C, we use the formula 2 to the n power, which is 2 times 3 here, which is 2 times 2 times 2 times 2 is going to give us 8. So the number of subsets in the set is 8 subsets. So that's basically it. Let me get something here. State the number of subsets. We're going to work on the exercises now. Exercise 1 says state the number of subsets found in each of the sets below and list at least 4 subsets. So basically, we're just calculating the number of subsets that can be found in the set, and then we are listing at least 4 subsets. Any of the 4 subsets that you would like to list, you are free to list it. It's any 4. So all right, let me just get this. My shapes will not be drawn properly since issue with the mouse. All right, let me pick a color. Let's use blue. So we have set A, and set A consists of a triangle, a square, and a rectangle. Triangle, square, and a rectangle. So we know that it's a beautiful 2n, which is going to give us, which is actually 2, and we know it's 3 elements, 2 times 3, and we worked an example like this before, so we just won't waste time working this out back. It's just 2 times 2 times 2, and we know that this is going to give us a total of 8 subsets. Yes, it's going to give us a total of 8 subsets, and you are free to list any 4 subsets of the set. So if you want, you can, all right, let's list the subsets. We can have the triangle. I'm just going to list 4 subsets, and we can have the square. We can have the square, and we can have the rectangle. We can have the square alone. Sorry, this is not a very nice square. We can have the square alone, and we can have the triangle alone. Yeah, so that would be my 4 subsets that I chose. So it's up to you. So basically, number 1, set A has a total of 8 subsets that are going to be found in that set. And it's up to you to choose any 4 subsets that you would like to choose. But this would be the 4 that I would choose, that I chose just for the sake of working out this exercise. So moving on. Okay, so we have number 2. Number 2 being set Q is equal to the vowels of the alphabet. So we are working number 2, right? Number 2, the vowels of the alphabet. So set Q is going to actually be equal to, we're going to have set Q is going to be A, the vowels of the alphabet, A, E, I, O, U. And again, if you're hearing a click every minute, a click in the video, it's because of this mouse that I'm using. So don't worry about that. A, E, I, O, U. And we know that there are 5 vowels in the alphabet. So if we were to calculate the number of subsets, we're going to have 2 to the n, which is actually 2 to the 5th power. And we already worked one not exercise, we worked one example where we have 2 times 2 times 2 times 2 times 2. And from the example we worked before with this same setting, we know that we'll have a total of, it's going to be 2 to the 5th power, which you know it's 2 times 2, 5 times, it's going to give us a total of 32 subsets. So if we are to list any of the elements within the, not elements, subsets within this subset of A, E, I, O, U, let me just write it here, E, I, all right, this isn't working out. Let me get this quickly where the internet disconnects again. A, E, I, O, U. So we can have, we listen at least 4 subsets. We can have A by itself. We can basically have E by itself. Listing the simplest of the subsets, I. And we can have the empty set as well. You can have the empty set as well. So 4 subsets is up to you. List any one of the subsets that you would like. So that's it. We have a total of 32 subsets in this set, set Q. So we're moving on to the other exercise. Get this out. Clear this off. All right, so we're looking at set of V. Set of V, we know we did what's set build our notation the last time. So by now we are all familiar with the setting, with a setting like this. So it's basically, all right, so we will have V. This set is actually equal to, it's a X is such that X is a set of even numbers less than 10. So we have a set of even numbers less than 10, which is going to give us 2, 4, 6, and 8 less than 10. So it's 1, 2, 3, 4. We basically have 4 elements in here. To find the number of subsets within the set, we will have 2 to the n power, which is equal to 2 to the 4th power, which is actually 2 times 2 times 2 times 2, which 2 2's 4, this 2 2's 4, 4 2's 8, and 8 2's 16, which is going to give us a total of 16 subsets. So this 2 is going to give us 4, and 4 times this 2 is going to give us 8, and 8 times this 2 here is going to give us, 8 times 2 is going to give us the product of 16. That's just to break it down. So we have the number of subsets found in set V, it's going to be 16 subsets in all. So if you would like to list your subsets, you list your subsets. Easiest, let's say let's use the empty set as 1. We have 2, and we have 4. We have 2 and we have 4. Then we can have 2 by itself, and we can have 4. 2 by itself, and we can have 4 by itself. So we have at least 4 subsets there. All right, so that's it for this one. V being, I apologize for the noise in the background. We have V being the X is such that X is a set of even numbers less than 10, which is 2, 4, 6, and 8. We have 2 to the n power, which is going to be 2 to the 4th power, since there are 4 elements in this set. So we have 2 times 2 times 2 times 2, which is going to give us 16. So we have a total of 16 subsets. And you can list any of the 4 subsets that you would like. Just give me a minute, please. All right, so that's it. So we are complete. We're finished with number 3. So we are moving on to number 4. Just let me clear this so we can have some space. And okay, let's clear. Here we go. We're moving on now. Number 4 of exercise 1. So we have number 4. Same set builder notation stuff came back here. So I know we're all familiar with this. So we have, it's an H, yes, a set H is equal to X. What am I saying? H, set H is, X is such that X is greater than 2 and less than 12. So we have X is greater than 2 and less than 12. So greater than 2, we know that we're starting from 3, 4, 5, 6, 7, 8, it's a big set, 9, 10, and we have 11. Since it's less than 12, we're stopping at 11. All right? No. All right, so we're stopping at 11 because it says that X is greater than 2 and less than 12. So it's starting from 3 and ending at 11. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8. 9 elements within this set. So 2 to the n power is going to equal to 2 to the 9th power. And you know that's going to be 2 times 9 itself. It's a lot to write, so just use 2 So the ninth power is going to equal to 512. That's a lot. 512. So we're going to have a product of 512 subsets. 2 to the ninth power 512 subsets. So you are to list any of the 4 subsets. So you can list the easiest. We can take the empty set. We can take 3 and we can take 4. We can take 7 and 8. 7 we can take 8. And we can take probably 10 by itself. All right, so that's it for that part. Listing any 4 elements. So 2 to the 9th. Good. So moving on to the next level, we're moving on to exercise 2. So exercise 2. All right, let me just get this set up. Where is the marker? So exercise 2. If set A is equal to 3, 6, 9, 12, 15, 18, and 21, and B is equal to 3, 6, 9, and set C is equal to 9 and 12, state whether the following statements are true or false, and write the statement using the symbols. So this is not much working. So set B is a subset of set A. Set B is a subset of set A. We have the elements of B being 3, 6, and 9. And if we look at set A, we have set A, which is 3, 6, and 9. So yes, we can say that set B is a subset of A. So in this case, it's going to be all right, so we can safely say that B is a subset of A. So if we are to write that, we can say B is, we use this, is a subset of A. All right, so C is not a subset of B. Set C is not a subset of B. Set C, we have 9 and 12, and we have B, 3, 6, and 9. So that is true. Set C is not a subset of B. That is true. And we can write that by saying set C is not a subset of B. Just change this and put this in a different color. Is not a subset of B. The empty set is a subset of A. That is true. We know that the empty set is a subset of all the sets. So we can say the empty set is a subset of A. All right, so last we have C is a subset of A. So we have set C being 9 and 12, and we know that 9 and 12 can be found in A. So we can say that set C, this is true, and we can say that C is a subset of A. Let me just change this color. so you know what is a subset of A. Now, last, we have a brain teaser where we can say that set A is a subset of the set of multiples of 3. Set A is a subset of the multiples of 3. If you look here, we have 3, 6, 9, 12, 15, 18, 21, and it is true. So set A is a subset of the multiples of 3. So if you want, you can write it. Set A is a multiple, is a subset of the multiples of 3. So that is it for today. So we have, all right, let me just take this off. I realize so when you move, it's here. Anyway, so let's take this off, take this off, take this off, take this off, and take this off. So we have notes for the next class, research on intersection and union of a set. Note that this lesson will be going for 20 marks. So the exercises in the lesson will be going for 20 marks. And yes, books will be checked in school. So that's it.